Today we're going to talk about square roots, radicals, and rational exponents. So you may have seen this symbol before and thought, that's the square root of 25, and that is correct. This symbol here doesn't just represent a square root though. It is called a radical symbol, and we could have other numbers out here to have different roots other than square root, like the third root or the fourth root. So this symbol is called a radical symbol, and the number underneath is called the radicand. What is a square root? Square root is opposite of squared. And remember, squared is a number times itself. So we would figure out what number times itself will give us this number. That's taking the square root. A perfect square is a number whose square root is a whole number. And I have a list of some perfect squares over here, 1 through 15. These are the perfect squares. When I take those 1 through 15 squared, I get these. So to take the square root, we would look at it backwards and find this number and go backwards. So the square root of 25 equals 5 because 5 squared is 25. 5 times 5 is 25. Square root of 81 is 9 because 9 squared, 9 times 9 is 81. 49 would be 7. Square root of 144 would be 12. And you guys can try the last two. Imaginary is what we say when there is a negative underneath the radical symbol. I cannot take the square root of a negative because if I would say, oh, 64 is 8, so it's just negative 8. But if I take negative 8 times negative 8, I end up with a positive 64. It's impossible to take a number times itself to get a negative because a negative times a negative is a positive. Non-perfect squares. For now, we are going to be estimating between two numbers. Yes, we could use a calculator and get answers as a decimal, but right now we're just going to be estimating. So the square root of 32 is not on my perfect list, but it falls between 25 and 36. So that means the square root is between 5 and 6. Square root of 75 is between 64 and 81, so that means the square root is between 8 and 9. The square root of 20 is between 16 and 25, so that would be 4 and 5. The square root of 7 between 4 and 9, so 2 and 3. And you guys can try the rest of those. For now, I will give you this list of perfect squares, but it would be great if you could memorize perfect squares up to 15. Radical versus exponential form. So, like I said before, sometimes we have a different number out here rather than just taking the square root. If there is no number there, it's a square root. We don't ever have a 2 to mean square root. We just see the symbol and we know it's automatic square root unless there's another number there. So there can be a number there and there can be an exponent on the inside. A is what's called the exponent on the inside, and B, this number on the outside, is called the index. When we are looking at changing radical form to a rational exponent, we remember inside over outside. This inside exponent goes on top of the fraction and the outside goes on the bottom. So inside over outside. We will have to go from radical to exponential and exponential to radical. So for example, we have this one down here. We keep whatever the base is, stays the base. We are only looking at the two numbers here and here. So 6 is on the inside, 3 is on the outside. I would put 6 over 3, inside over outside. We could simplify this. 6 divided by 3 is 2, but if you keep it like this, for now, that's okay. This one gives us the radical, or the rational, so we need to write the radical. Again, I put the base on the inside over outside, so 5, 8. Okay, it is important that you put this outside number kind of in the radical symbol rather than putting it like this. This would be 8 times the square root, and this is the 8th root, and those are very different. So make sure when you're writing the outside number, you put it very small in kind of inside of that radical symbol. The next one, we have W inside over outside. So there's no outside number. That does not mean it's a 0, that does not mean it's a 1. We think back to what we did here with square roots. That means it's a 2. If there's no number on the outside, the index is a 2. Again, we could simplify this to W to the 4th, or we can leave it alone. This one, let's write as a radical. 5r is in parentheses, so I'm going to leave 5r in the parentheses because this whole thing is to the exponent, not just the r. Inside over outside. So the 9th root of 5r cubed. Again, we have parentheses, so I'm going to keep 3v in the parentheses. Exponent inside over outside. Okay, next one, we have 1 to the 1/2 power. So I put 2c, and 1 would go on the inside, but an exponent of 1 doesn't change anything, so I don't really need it. And a 2 would go on the outside, but like I said before, we never need to write a 2 on the outside because it's square root if we don't have that. So I can leave my answer like this. If we have a square root, just the square root with an exponent of 1, it will always be 1/2. So kind of similarly, looking at this one, I don't have a number on the inside or the outside. That is 1/2. Okay, same thing with this last one. I know it looks a little confusing because there's an x and a y. We're going to say this is x to the 4th, y to the 9th, put it in parentheses. Together, their exponent is a 1, and this is square root, so 1/2, again on that one. Last thing is when we have numbers, which are perfect, squares or perfect cubes, or so on, we can actually simplify them rather than just rewriting them. So starting by rewriting 100 to the 1/2, we just talked about 1/2 is just square root. So the square root of 100, well, the square root of 100 is 10, and there's no exponent, so I leave it as 10. 27 to the 2/3. So 27 inside over outside. When we simplify this, we want to start with the radical part. So I'm going to ignore the exponent, and I'm going to take the cube root of 27. So that means I'm looking at the perfect cube list, finding 27. Cube root of 27 is 3. And then this exponent on the outside, or on the inside, we just carry with us 3 squared. So 3 squared is 9. So 27 to the 2/3 power equals 9. 625, we have inside over outside. Again, we start with the radical part, so the 4th root, we're going to look at our x to the 4th column, 625, that is 5. Bring along the exponent, 5 to the 3rd power is 125. And let's look at one more. We have 9 inside over outside. If it's a 2, I don't need to write it. So I'm going to start by taking the square root of 9, which is 3. Bring along the exponent. 3 to the 3rd power is 27. Again, we can use calculators for this as well. I just wanted to show you how it works rather than just letting your calculator do the work.